0.5 centimeters. And in a similar fashion, take the balancing length for each 5 degrees centigrade. The steps of 5 degrees centigrade, that is 80 degrees centigrade, that's 75 degrees centigrade, that's 70 degrees centigrade, like that. Take up to 35 degrees centigrade. So this is the balancing point. And after that, draw a graph between temperature and S value, that is R value. So non-resistance value. So this is the non-resistance knob. And how can we calculate the non-resistance value? So at first, place this multimeter in a resistance side, that is here we place this multimeter on 200 ohms resistance side, and take two side probes knobs, two side probes wires, and connect these two knobs on the calendar and Griffiths bridge to multimeter, and switch on the multimeter, and this multimeter shows the non-resistance value. So this is the procedure for PRT experiment. So next one is ultrasonic interferometer. Aim of this experiment is to measure the velocity of ultrasonic wave in a given liquid. So apparatus, high frequency generator and measuring cell, and this is the formula V is equal to lambda into F meters per second, where lambda is the wavelength of ultrasonic wave and F is the frequency of ultrasonic wave. And this is a high frequency generator connecting with a measuring cell consisting of a reflector plate and a standing wave inside that measuring cell. So this is the diagram for ultrasonic. So these are the operators. So high frequency generator, this is the high frequency generator consisting of ammeter and this is the frequency knob. This is the frequency knob. And this is the measuring cell. So measuring cell means it is a double walled cell and consisting of a screw gauge in a vertical position. So at first fix the frequency value to 4 megahertz and connect the output of high frequency generator to measuring cell. At first adjust these two knobs until you get clear deflections in the ammeter. So this is the tabular form. Number of deflections, PSR, HSR, HSR into LC, A plus B, difference between 5 deflections, and lambda equal to 2D by 5. So at first pour the given liquid in the measuring cell and this is the reflector plate. So place that reflector plate, immerse the reflector plate in the given liquid. So this is the pitch scale reading. So this is pitch scale and this is the head scale. Now rotate this screw slowly and observe the deflections in the ammeter and observe minimum and maximum values for the deflections. So rotate the screw slowly and observe maximum and minimum values for the deflections. So it is giving 10 as a minimum and 80 as a maximum. So at first take the reading on the screw gauge at this position. Take the reading on pitch scale and head scale. And note down the values and take that first one as a number 0 and note down the PSR value and HSR value. Sorry, this is not PSR. So PSR value is 23.5 and HSR value is 19. Okay, next HSR into least count, that is 19 into 0.01 millimeters. So that is 0.19. And again rotate the screw and observe the deflections in the ammeter. Now after 5 oscillations in the ammeter, again take the reading on pitch scale and head scale. So after 5 deflections in the ammeter, take the reading on PSR and HSR. Now PSR is 22.5. That means after 5 deflections, PSR value is 22.5 and HSR value is 45. So next HSR into least count, that is 0.45. After that take A plus B, that is PSR plus HSR into LC in this column, and after that difference, calculate the difference between 5 deflections and from that calculate lambda equal to 2D by 5. Solar cell. The aim of this experiment is to study the characteristics of solar cell and to calculate its fill factor. Operates solar cell kit, connecting probes, and formula. Fill factor for a particular light intensity is equal to P maximum by ISC into VOC, where P maximum means maximum power ISC means short circuit current, VOC means open circuit voltage. And this is the circuit diagram for solar cell, and this is the model graph. So this is the model graph for solar cell experiment. So this is the solar cell, and this is solar cell kit consisting of a voltmeter and ammeter. So voltmeter, and this is voltmeter, and this is ammeter, and this is a load resistance knob, and these are two multimeters. One is in DC voltage mode, so this is in DC voltage mode, and another one is in AC current mode, sorry, DC current mode. So at first, connect the two knobs in the kit to solar cell, which is placed in presence of sun rays. So connect the two knobs in the solar cell kit to solar cell. Next, after that, connect the voltmeter knobs in the solar kit to the multimeter, which is in direct voltage mode. So connect the both knobs of the voltmeter to multimeter. Next, after that, connect the two knobs of ammeter in the solar cell kit to another multimeter, which is in a direct